REI 12 linear programming example. The area of a parking lot is 600 square yards. A car requires 6 square yards and a bus needs 30 square yards. The attendant can only oversee 60 vehicles. If a car is charged $250 and a bus is charged $750, how many of each should be accepted to maximize income? So first we want to think about our objective function. How do we earn money here? The profit is earned by charging people to park their car. You charge $2.50 per car. So we'll let X represent the number of cars and Y represent the number of buses. And you charge $7.50 per bus. So our objective function is profit. To earn profit, we would do $2.50 per car plus $7.50 per bus. We have some limitations though. We have limitations in how many vehicles can be in our lot, and we have a limitation with the amount of space the vehicles can take up. That's the area. So if we look at our limitations, the amount of area, so here we're talking about our constraints or our limitations. The area has to be at most 600 yards. No more than 600, since it says the area of the parking lot is 600 yards. Each car is 6 yards, so that's $6 per X, and each bus is 30 yards, so that's 30 per Y. So again, these numbers all have to do with the area. The area the car and the bus takes up has to have a total less than or equal to 600. Then we just have the attendant, and their ability in this lot is to only have 60 vehicles. So the number of cars plus the number of buses has to be less than or equal to 60. So we've written our constraints. Solving a linear programming problem is just graphing a system of inequalities. So let's graph those two inequalities. I suggest finding the X and the Y intercept and using the X and the Y intercept to determine what your scale should be. So my X intercept is where the line crosses the X-axis. All the points on the X-axis have a Y value of 0. So if I substitute 0 for Y, I'm left with 6X equals 600. Divide both sides by 6, and you would get an X value of 100. So again, I'm just making like a mini table and thinking about 2 points only, and those 2 points are the X and the Y intercept. The Y-intercept has an X value of 0, because if you're on the Y-axis, you didn't move left or right, you only moved up or down. So plug in 0 for X, and you get 6 times 0, which is 0, which is why I'm covering it up. It's just 0. 30Y equals 600. Divide both sides by 30, and Y equals 20. So 0, 20 is the Y-intercept. This has meaning in context of the inequality. This is telling me that if I had no buses, I could park 100 cars. If I had no cars, I could park 20 buses. But already we know that this X-intercept of 100, 0 is not going to be a possible option because it doesn't fit the other inequality in the problem, because the attendant can only oversee 60 vehicles. So 100 cars isn't going to be one of our options. But it is a point on the line that we're going to graph. Let's do our X and Y intercepts here. When X is 0, Y is 60. When Y is 0, X is 60. So we have fairly big numbers. I'm not going to use a scale of 1, that's for sure. I think I'll just use a scale of 10 and count up to 100 on both my X and my Y axis. Something else we want to consider here is, should we use anything more than the first quadrant? Since we're talking about the number of cars and the number of buses, we can't have a negative amount. So we're going to add to our constraints. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. So now we're looking at graphing those inequalities. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. My x-axis represents the number of cars. My y-axis represents the number of buses, and it is important to label what your x and your y-axis represent. So if we just plot our two intercepts, 100, 0, and 0, 20, is our first inequality. 6x plus 30y has to be less than or equal to 600. Trying to draw that straight line as possible. And then our other inequality is 0, 60, and 60, 0. And both of these inequalities are less than or equal, which means obviously if we use the test point 0, 0, 0 is less than 60, 0 is less than 600. They're both going to be shaded towards the origin. So where is the overlapping shaded region? If I shade this one towards the origin, and I shade this line towards the origin, we see that this is red only, so that is not an overlapping region. This is blue only, that is not an overlapping region. The overlapping region is right here. I'm going to darken that just so that we can all see. This is the feasible region, which means that any point in this area of the overlapping shaded regions would be a solution to our system of inequalities. But we're not only trying to find a solution, we're trying to find the best solution to maximize profit. In order to do that, we want the intersection points of the vertices. So we have 0, 0, we have 0, 20, so I'm going to write these down, 0, 0, 0, 20, we have 60, 0, those were easy to come up with, and then we have this point right here that we really aren't sure what that point is because our scale was too large to really see exactly what that point of intersection is. However, it's the point of intersection between the two lines, 6x plus 30y equals 600, and x plus y equals 60. It's the intersection of these two lines. I'm going to use system of equations, and I'm going to solve to find my point of intersection. I will multiply everything in the second equation by negative 6, giving me negative 6x minus 6y equals negative 360. Now I can add these two equations. The negative 6x and the positive 6x are eliminated. That leaves me with 24y equals positive 240. Divide both sides by 24 and y equals 10. So I know that I have a y value of 10. It was just very difficult for me to see that on my graph as the point of intersection, considering I didn't use a ruler and this was just a sketch. So this algebraic method found that point of intersection precisely. I know I have a y value of 10. If I go back in either one of my equations, if y is 10, x has to be 50. So that last point of intersection right here, that point of intersection is 50, 10. And again, it was important to verify that and know that precisely, and I use systems of equations to find that point of intersection. So now I have my 4 vertices that I'm going to substitute into my profit function in order to determine which one brings in the highest income for this parking lot. So obviously 0, 0 doesn't make us any money. Again, our profit function was $2.50 per car plus $7.50 per bus. 0, 20 would mean 20 buses, and 20 buses would bring in $150. So 0, 20 brings in $150. 60, 0 would be 60 cars. 60 times 2.5 is $150 as well. And our last option is that point of intersection 50, 10. So 50 cars would be 50 times 2.5, which is 125. And 10 buses would be 7.5 times 10, which is 75. And 125 plus 75 is $200. Which one brings in the most money? This last option of 50, 10. So our solution to this problem, we would tell them that your maximum profit is earned when you have 50 cars parked and 10 buses. That is your best option. Good luck.